Unit 4 Review Question 1. 3 pizzas are shared among 8 friends. And our question is, what fraction of a pizza does each friend get? So notice right here, I drew a picture of this scenario. So there's 3 pizzas. And since there's 8 friends, I thought it would be easiest if I cut each pizza into 8 equal pieces. That way, to see what each friend would get if they shared it equally, each friend would get 1 slice from each pizza. Now 1 slice is 1/8 of a pizza since it's cut into 8 equal pieces. So this represents friend 1's piece, friends 2 pieces, etc. And then I put all of friend 1's pieces together, and relative to the unit of 1 pizza, because it says what fraction of a pizza does each friend get, there are 3 out of a total of 8 slices. Okay, so how do we see this from the context of the problem? Well, notice that this is a quotient model or a division model where we're sharing equally into a number of groups. Okay, the 8 friends are sharing the 3 pizzas. Okay, so in the numerator you put what's being shared, which is 3 pizzas. And in the denominator you put how many people or things are sharing what's in the numerator. So we have 8 friends. Okay. So I use the units to help me organize this fraction, and the end result is 3/8 of a pizza per friend. Okay. And I could read pizza per friend by looking at this fraction, and again noting that that is the fraction of what I'm finding, the fraction of a pizza per friend. Let's look at the next one. There are 15 freshmen in an introductory algebra class of 35 students. And we are asked what fraction of the students are freshmen. Okay. So we're asked for the fraction of the students, so that is going to be our whole. Our denominator is going to be the number of students, and we're asked for a particular type of student, which is freshmen. So this is going to be a part. So since freshmen are students, that means they're a part of this whole. So looking down here, this is it's also a ratio, and it's a part-whole model where we have a part in the numerator and a whole in the denominator. Okay. So this diagram represents a scenario. There are 35 objects representing the 35 total students. Okay. The 15 that are freshmen are shaded purple, and they have little F's in them to indicate they're freshmen. Okay. So the fraction of students that are freshmen are the 15 freshmen, the part of the class that are freshmen, over the total number of people or students in the class. Okay. And I use the units to help me again, and our end result would be 15/35. So the fraction of the students that are freshmen are 15/35 of the students. Let's look at the next one. Jeff answered 13 questions correctly on a quiz and 5 questions incorrectly. And here comes the question. What is the ratio of correct questions to incorrect questions? So notice this one didn't say what is the fraction of correct questions to incorrect questions, even though that wouldn't necessarily be wrong. The word ratio is used typically when we have either a part-to-whole model like the last problem or a part-to-part model. And this is where we have a part in the numerator and a different part in the denominator. Okay, so the whole here would be all the questions on the quiz. If you take the 2 parts, the correct questions and the incorrect questions, and combine them, it's the total number of questions. But correct questions and incorrect questions do not overlap. They're either correct or not. And you could look for the word ratio of. That helps you to see that it's a ratio, either part to part or part to whole. The first part says correct questions, so that's going to be part 1, which is going to go in our numerator. The word 2 indicates the part that's going to go in the denominator. So this is part 2. So now we'll put the number of correct questions in the numerator and the number of incorrect questions in the denominator. Okay. So this diagram represents this. There's 13 marked C for correct and 5 marked I for incorrect. Okay. So it's 13 over 5. Okay. So notice the total number of questions is 18. So what percent or grade Jeff might get would be 13 out of the 18. But this is comparing how many correct to the number of incorrect. Let's look at the next one. It takes 2 friends 4 hours to hike 3 miles. And our question asks, what fractions of miles to hours did they hike? And then it looks like there's a second question. What fractions of hours to miles did they hike? Okay. And those questions seem almost identical, even to me as I was saying them, but let's notice how they're a little bit different. So we have fraction of, and it says miles to hours. When you see the word to, that's an indicator that this is going to be the numerator before the 2 and the denominator is after the 2. So here the numerator is miles, the denominator is hours. In the second one it says fractions of hours to miles. So here's hours first, then miles. Okay. So hours is going to be in the numerator and miles is going to be in the denominator. Okay. Also notice in our chart below that this is a rate model. Okay, and a rate is a special type of ratio. It's still a ratio, but it's when we're comparing different types of units in the numerator and denominator. So here they have miles and hours as an example. So in the last problem, we were comparing incorrect questions to correct questions, but they were both types of questions. Here, we're measuring miles, which is a measure of distance, and we're comparing that to time, which is measure hours, which is a measure of time. Okay. When we combine these two, sometimes we say miles to hours, but you probably heard miles per hour. Okay, and that's a whole new type of measurement called speed. So we have special names for these, and we call them rates when they're 2 different types of units that make a new type of unit. Okay, so let's do the first one. So the first one is miles over hours. And there are 3 miles, so that 3 is in the numerator, and 4 hours in the denominator. For the second question, we have hours to miles, so hours is in the numerator, and miles is in the denominator. And again, the number of hours was 4, and the number of miles was 3. Let's look at the next one. So in question 5, we want to determine the fraction represented by the shaded area using the given unit. Okay. So notice we have 3 different types of units here, and our fraction is going to be different depending on what the unit is. So remember, the unit is what we are calling 1. Okay. So here we're saying that 1 circle is the unit. And now we have this image. We want to see how much of this 1 circle is shaded. Okay, so notice it's cut into equally sized pieces. Okay, and we require that for fractions, that all the pieces are the same size. So the denominator is the number of pieces in the unit. And the numerator, since we want the shaded area, the numerator is the number of pieces shaded. Okay. And this will actually be the case for all of these problems. In each case, there's going to be 2 pieces shaded, but the number of pieces in the unit will change. Okay. So here, if we look at the circle, the shape is equivalent to this. We have 1, 2, 3, 4, 5, 6, 7, 8 total pieces, and 2 are shaded. Okay. So 2/8 of this circle is shaded. Now here, this looks like half a circle. Okay, So I'm going to try to draw this in a special way. Maybe we could say that this half of the circle is the unit. And I use the word half, but now we're saying that this equals 1. Okay, so maybe this is a pizza that you buy and they tell you that this is 1 serving. So we might want to say, well, how much of 1 serving did you have? Well, just focusing on this, the unit, okay, there are 1, 2, 3, 4 equal pieces. So 4 out of 4 would equal 1. But we don't have all 4. We have 2 out of the 4 shaded. Okay. So we found the unit. We counted how many equal pieces it's broken into. That's the denominator. And the number shaded is still 2. Now let's look at this last unit. I'm just going to erase this blue so we don't get distracted. Okay. Now I'm going to reference this circle. If you look at maybe this piece right here, that's equivalent to the shape of this piece. Okay, so we're saying that this is 1, and this one is broken into 2 equal pieces. Okay, so if this is 1, each one of these pieces is now 1/2. Okay, so now we know the denominator is 2. These shaded pieces are over here, but I think you can agree that we could think about moving or shifting them anywhere we want. Okay. So I'm just going to use a highlighter and say we'll move this shaded piece to this one to here, this one to here. Relative to this unit, both pieces would be shaded. Okay, so the unit is broken into 2 pieces. 2 of the pieces are shaded. Okay, and notice this also equals the number 1. If you have 2 out of 2, you have 1. And that makes sense because relative to this, that's exactly how much we have shaded. If we're saying that this is a unit and this equals 1, well then these 2 pieces would equal 1.